I'm Piper and this is my Physics Lab 3. So the purpose of this lab is to find the mass of a black hole using the orbit of a star, and that's what we'll be doing in part 1. And then we use this mass to find the initial velocity that the ship needs to leave the planet without crashing into the black hole. The physics principles are the momentum principle and Newton's universal law of gravitation. And here's my results from part 1 and part 2. So the first main physics idea is the momentum principle, which is also Newton's second law. F net is the change in momentum divided by the change in time, and we can break up F net into the parallel force and the perpendicular force. And then when we plug in change in momentum over change in time for force, we get this. And then we also use the gravitational force equation and rearrange it to find the mass of the black hole. So for part 1, we're going to find the mass of the black hole. The system is the black hole and the surroundings is the star. So first I put in the initial conditions. I have the mass of the star, the gravitational constant, and the number of seconds in a day. And then to find momentum, we do mass times velocity. And we calculate change in momentum divided by change in time. And we use that to find F net. And then we find the mass of the black hole using the rearranged gravity equation. So here's my results from part 1. And these are the numbers that I got. So for part 2, we want to find the initial velocity of the spaceship so that it doesn't crash into the black hole. This system is the spaceship, and the surroundings are the star and the black hole. So for this, I put in my black hole mass that I got from part 1. We have the constants, and then I got the speeds, the initial speed, using trial and error to see the closest that I could get to the black hole without crashing into it. And then we find force to get the position update. And here are my part 2 results. So the errors in the lab are that it's a simulation, so in real life there's going to be other factors affecting the position of the spaceship. And also, for part 2, I used trial and error to find the initial velocity, which means that it won't be the exact velocity that I need to get closest to the black hole. So for our questions, we want to know, how is the net force and its parallel and perpendicular components different from the rate of change of momentum and its components? So the net force is equal to change in momentum over change in time. And this means that the net force and the rate of change in momentum are the same mathematically. But the change of momentum is easier to find because we only need the velocity and mass, but the net force, we need to know every factor exerting a force on the system. So for part 2, we have, what if we orbit around the black hole? And we want to know what velocity we would need, the initial velocity. So the ship would need a similar velocity to the planet, but the y component needs to be bigger and the x component needs to be smaller. And here's the speeds that I found, and here's my results.